Okay. Share slides. Okay, great. Right. Thank you everybody for joining. Um, Today's meetup is about virtualization with OpenShift. It's a topic that we wanted to cover, right, for I think for quite some time really. Because I think the feature itself, right, has been incorporated with OpenShift for I think a few months already, and it's a topic that was we wanted to be gather enough information and see where the technology is at, right? Because at the start it wasn't there yet, right? Wasn't that what matured in that sense, but it just wasn't ready, right, for us to go out there and talk about it. But previously, I think now we have a lot of engagements with many users and many of our customers on the topic itself, and we felt that it was a good time for us to revisit, and that is where we wanted to do this session today, right, and talk about it. So with us today we have a special guest, right, Rahul. Rahul is our go-to-market specialist for cloud native infrastructure, and we have him today to go through what is virtualization with OpenShift all about. So yeah, Rahul, I will pass the mic to you.
Oh, thank you, Derek, for making me special. All right. So, especially I would like to thank Anthony and Derek for arranging this. The idea is that we want to pitch this idea and see how you all feel about this. And once you try this, we would like to get your feedback as well. How do you think virtualization on OpenShift makes a difference to your organization? So we have a good amount of content. Let's get straight to the topic. Okay, so today we will talk about a little bit about OpenShift virtualization. From how do we think from a Red Hat perspective? What are the different ways our customers are using OpenShift, and what are the different things they build on top of OpenShift for their businesses? Then some of the technical aspects behind it, how exactly this is being architected, how exactly things works behind this, and a wonderful demo by Anthony as well. So let's start with a question. So next slide, Derek. So the question is, let's say you all are sitting in a stadium. Let's say the Singapore Stadium, the OCBC Stadium, and you are sitting at the top seat over there at that stadium. And this is a watertight stadium. Once water is in, the water doesn't escape. And now we are going to fill this stadium with water in such a way that every other minute the drops doubles. So the first minute, it's one single drop. The second minute, it's two drops. The third minute, it's four drops. And the fourth minute, it's eight drops, and so on. So water doubles every other minute. How much time do you think it takes to fill up the stadium? You can put the answers in the chat box.
Mhm.
It can be hours, minutes, years, decades, whatever comes to your mind. Don't think too much. Just put your answers in the chat box. The question is, how much time does it take to fill up the stadium when we fill the stadium in such a way that the number of drops doubles every other minute? Okay.
Mind-boggling. How big is the stadium first?
I totally get that. I totally get that. But just from a thinking perspective, right? A thinking exercise. Okay. So
I'm thinking of my engineering mind now.
exactly, there is calculus and differentiation involved in this calculation. Yeah. Okay. So the answer is almost close to 47 minutes. It takes only 47 minutes to fill up the whole stadium. The interesting fact is, at the 45th minute, the stadium was 93% empty.
Mm.
We sitting at the top of the seat, we never would have anticipated that in the next 2 minutes, the stadium would be full. And that's a kind of disruption which is happening around us. We did not have that exponential thinking to think that in the next 2 minutes, this will be full and we will be able to escape. So that's the kind of disruption which is happening around for our businesses as well. Say, for example, COVID-19 is a classic example. We never anticipated that this could be a widespread. If we would have known this, we would have stopped it earlier. The same is there for the climate changes, right? At one point in time, and another zero point 0.5 degrees of rise in temperature, we will not be here. So that is so exponential, and we need to have that exponential thinking to address this kind of disruption. So what exactly is exponential thinking? So Derek, one slide forward. So before we talk about exponential thinking, what is incremental thinking? So incremental thinking, meaning to say that when we want to go from point A to point B, we take incremental steps, and it is predictable. We know that at some point in time we will reach there, and we take baby steps to get there. From a business standpoint, every year we want to have 10% increase in year over year business, or 20% or 30% year over business in terms of revenue, or things like that, right? That's how we think incrementally. So it's incremental addition to the business. But when we think about exponential, exponential is all about 10 times or 20 times. And that's exactly what Tesla did. One click, Derek. So Tesla, founded in 2003, they were silently disrupting this car industry. Nobody noticed them. But now, having that exponential thinking in them, they now they have that exponential business with them. And other car makers are out of it. They are already thinking, they are into that incremental thinking mode where they sell more and more cars every year. But Tesla did something different. But when we have exponential thinking, we need to be patient, in the sense that if we want to see the results, there is a waiting period, because we have to persistently and consistently do things every other moment. And that's what Tesla did as well. Back in 2009, they were almost into bankruptcy. They had financial troubles, but they consistently and persistently kept on doing things so that they captured that results. Now, bringing this idea, direct one slide forward, and bringing this idea of incremental thinking and exponential thinking into the technology in the world which we live. And today we have multiple types of environment: physical, virtual, or containers, and so on. So prominently, we are all into virtualized world, and some of us are moving into containers, and some of them already moved into containers in a big way as well. But most of us are into a virtualized world. So top below the graph, we can see that we have virtual machines, and today we are having most of our environment into virtualized world, and this is a traditional environment. So when we have traditional environment, we are thinking incrementally, which means we want to make the max out of that environment in terms of efficiencies. We want to be productive. We keep on increasing efficiencies in this world, that VM world, so that I can get more and more productive. That's an incremental way of doing things. Probably I will say that, okay, I have one administrator managing 10,000 VMs, and in next year I want the same administrator managing 20,000 VMs by having automation, or maybe having better workflows and things like that. So it's an incremental way of thinking, where we skews that environment to get the maximum out of that existing environments. On the top of the graph, we have containers. That's a place where the next big business idea is happening. That's a place where we are exploring in the sense, we are thinking about innovation, we are thinking about growth, we are thinking about speed and flexibility. In the other side, where we have exploit, we are thinking about cost efficiencies, we are thinking about reducing the risk, we are thinking about having quality, we are thinking about having maximum uptime and things like that. In the exploration world, where we think about exponential thinking, all about risk, right? We are putting more and more risk so that we can get that 10x into our businesses. So what happens if we have a platform where we can have both thought process implemented onto it. That is one slide forward. And that could be one platform where we can have incremental and exponential thinking. At the same time, take your next business, big business idea with speed, scale, and stability to the market. And one such platform could be OpenShift. That is one slide more forward. So how does OpenShift do this? How do we exactly plan to have this incremental and exponential thinking coming together? Derek, one slide forward. So today, as Derek mentioned when we started, we were in that nascent mode few months before where we were getting mature on this. Today, OpenShift supports that virtual machines on top of our platform, which simply means that you can take your virtual machines from your existing virtualization environment, move it to move it to OpenShift world. This means that we are rehosting. That means simply moving your workload from one platform to another platform where you are trying to get where we are trying to leverage all the good things about cloud native world. We are actually exploiting that new technology to get the maximum efficiencies in running virtual machines. So we are not touching the application layer. We are just making sure that our infrastructure is getting more efficient. The application innovation is the next thing. So we move over here and then we try to get all the good things behind the cloud native world. So this is a new thing. This is, we can't compare the OpenShift virtualization or Kubernetes virtualization with a VMware or Red Hat virtualization or OpenStack. Is a different way of running things, which also means that there is a learning curve. We need to have a different mindset in operating virtual machines on OpenShift. And is this the place where we stop? Probably not. This is a landing zone where we bring things over here. Okay, I took my first step in bringing my virtual machines over here. Depending upon the workload, I get all the efficiencies, but we take this to the next step. And who have done this? As an example, recently, in the beginning of this year, Shahi Binden, who is a e-commerce platform in Turkey, they are one of the largest e-commerce platform in Turkey. They moved around 2,500 virtual machines onto OpenShift. So where they have hosted different types of workloads like databases, distributed databases, they have moved their middleware applications and their Elastic layer, the Kafka layer, all those things as virtual machines into OpenShift. And they are not stopping there. They are going to take the next journey. So how does the next journey looks like? Derek, one slide forward. So OpenShift as a platform, we talked about, they can do virtual machines. It can support virtual machines, run your virtual machines where you rehost, move your virtual machines here. After that, you can containerize. Either you develop your applications from the scratch as a container or serverless, or you can move and then refactor or re-platform into a containers world. So that's a place where we give developer experience, mostly for application development, where we develop an application, deploy an application, scale, and then manage and operate in a safe and secured manner, automated, secured manner. So that's more about how you take your next big business idea, implement that as an application on top of your OpenShift, and get to the market much faster. And who have done this? This is a very interesting story for me. A BMW. Uh, a group of friends, let's say we all of us are traveling to a long distance trip. We are going in a three different cars. So three different cars as a convoy, we all are going for a long trip. In between, we want to take a break. What we normally do is that we normally get on a phone, all the three cars, we make a phone call, we put on a speaker, and then decide where to take a break. So we might take a break at a restaurant, or we want to say that, okay, we take a break at a lakeside or something like that. But what BMW has done is they created a voting app on the dashboard where you can put all the different options and ask everybody to vote on that. So once the voting is being done, once the majority is there on the voting, the car reroutes to that destination for all the three cars. So that's a driver experience. So BMW enhanced that using, as this was done as a POC on OpenShift, and they are now taking as a next step where they can provide, let's say for example, where is the next charging stop, how much amount of time does it take for the charging, how much money I have to pay for the charging, and what type of chargers are available, etc. So they are enhancing the driver experience by putting their code on OpenShift using serverless. So that's one great story which I personally like. And from there, how do we do the next thing? So Derek, if you move forward. So we talked about virtual machines where we had get incremental efficiencies by adopting a cloud native platform. Then we get to the exponential part where we bring next big business idea by running on containers and serverless. Now, how about providing a next business opportunity or customer experience? Having exploiting the data side of things, bringing data into a platform using AI ML as a technology to create insights for the business. A pretty interesting story is NTT. NTT in Japan. So they created this AI ML platform on OpenShift. What they have done is in Tokyo and surrounding places, there's less labor available, especially during COVID times. There was less labor in the retail stores. So it was impossible to get people work on the retail stores and provide services to the customers. So let's say I'm going to the store, I am trying to find out some product. I'm trying to find out a sake or something, right? I'm not able to find it. The camera which sits on the corner of the shop, it's an AI camera, understands that I'm wandering around, I'm not able to find a product. It sends a message back to the seller at the back end. Immediately the seller appears in front of the customer and helps him or her to get that product. That experience, and that actually helped them to increase the sales as well as reduce the shelf life of the products and so on. So many different benefits they have achieved. But the interesting fact is, so they people are able to innovate in very different ways, using data, using containers, using technology. Technology becomes an enabler for them to do such kind of new activities. So we work with NVIDIA and so on to get this things done, which we will talk later much more. But the idea is that that's a one single platform which can help you to provide, Derek, one slide move forward, which can help you to provide that incremental thinking as well as the exponential thinking from a technology perspective. I'm not talking about business perspective. You might have a business idea that can be implemented on a technology platform. So as a one single hybrid platform where you can run your applications on virtual machines, that's rehosting. Bring your virtual machines to OpenShift rehosting, perfectly fine. Then you take the next step where you build your applications into microservices, where you exploit the best benefits out of the OpenShift platform using containers and serverless. So you can run your applications on containers. And the third thing is getting that next business value in terms of running AI ML capabilities. So one single platform to run all different types of capabilities. With that, I pass it back to Derek to talk more about virtualization technology itself.
Hey, thanks, Rahul. Right. So let me cover a bit more, right, on OpenShift virtualization before I pass it off to Anthony, right, to go into the just a short demonstration, right. Along the way, if you guys have any questions, feel free to unmute yourself or place it in the chat, right. We have quite a number of rehatters here that can probably find some answers for you, right, if you have any questions. Yeah. So, like I mentioned, right, KubeVirt itself, which is the technology that OpenShift virtualization is based on, right, became a CNCF incubating project, right, since April 2022. That's why I mentioned, right, it has really been integrated with OpenShift for quite a while now, like a few months back. But definitely we wanted to be ready to speak to our user groups as well as our customers as well on the technology itself. But KubeVirt, has been there and it's part of CNCF. And there's a lot of collaboration in the community with KubeVirt, with other open source technologies out there like Rook or Prometheus or Maltus, right? So as what Rahul also touched a bit on, right? It's virtual machines, putting it as a containers, event essentially is how we are utilizing KVM, right? Previously the technology KVM itself, based on when we're doing Ref, right? A lot of the engineering in Red Hat, has been doing Ref for very long, and now we have put a lot of investment, right, or put a lot of work, right, from the engineers that were doing KVM to OpenShift Virtualization itself, right? So underlying resources that you need is relatively similar. It's also you need to compute and network as well as centralized storage. So essentially, you have the virtual machines which are isolated on the hardware, and then that's where the idea of containers came about. How can we isolate the process within the virtual machines? And what OpenShift is trying to bring, as what Rahul touched on, is how we can run both virtual machines as well as containers, right, on a single pane of glass and on a single platform. Right, we want to be able to inherit, right, a lot of the features and functions from Kubernetes, right? For example, scheduling, high availability, attach and detach resources, containerizing the virtual machines itself, right? There are limitations, definitely, because like for example, CPU and RAM are dictated by the libvirt itself. And then for example, operating system, right, itself, basically is similar to how you're doing it today on KVM, right? It's probably usage of Linux and Windows KS operating system itself. In terms of for the VM disk, right, later on, I think you can see as well in the demo, right? Usage of the PVCs, right, for VM disk. And then the containerized data importer helps to import those VM images itself. For network, is also relatively similar. It's inherit from a containerization perspective, right? It's inherited by the pod network, right, by default. If there's needed for a direct connection to external network, right, Malters needs to be enabled. Right, virtual machines, a container world, right? We want to provide, as what Rahul mentioned, we want to provide a transition for application components. As today we are not trying to use this platform to replace the entire virtualization stack that our users have or organizations have today. What we are trying to achieve here is to provide a measure for customers or users to place application workload on the VM and look at how they can move and containerize it in the near future. Right, so that is what OpenShift Virtualization as a whole. I will pass my time to Anthony, right, to go through the demo itself.
Okay. Hi everyone. Right. We are in the same room, so hopefully
you still need me to move the slides for you.
I'll take over.
Okay, yeah.
Let me just take over the show. Okay. Okay, I'm just going to go quite quickly over some of these features that we have, because I'm going to show you how it looks like from the actual OCP environment itself. So as what Derek mentioned, feel free to stop us, if there is any questions, we will just try to answer them. Okay, so you can see over here that we are actually able to, for instance, now have virtual machines and containers, right, running together within the same namespace, right? So essentially what's going on is that the VM is running inside the container pod, right? We also have other processes like libvirt that is running that allows this to happen. We are able to have the virtual machines connected to the pod networks, and because of that, we are actually able to do things like service and routes, which we will show you very quickly how it can look like, let's say from a pod that's running within other namespaces, able to reach the services that was created using the virtual machines, right? In our case, we have Apache running on the two VMs that we have, and we are able to reach that service from other ports. So those are all possible, right? Because from this perspective, it's really not any different from the other pods that's running within Kubernetes, right? So after that, we can also do things like network policies, which essentially is like firewall, right? In a way to control the access from a traffic perspective, let's say ingress traffic, for instance. Then after which we are able to do things like creating from a template. It's a bit similar to how you typically may do, right, in the virtualized world, right? You have a template, you want to create a VM, right? Let's say a RHEL 7, a RHEL 8, a RHEL 9, right? Or it can be a Windows VM. So in our case, we also have this kind of template that you can actually select. So from a template perspective, you can say, okay, what kind of NIC cards I actually want to assign, right? So by default, you always have the port networking, right? And after which you can actually have a second NIC card or a third or fourth, right? Depending on what kind of configurations we have set up. In our environment, we have two NICs for the bare metal, right? So you will see that we have another NIC card that can be used to assigned to the port that we have, right? So multi-NIC cards is definitely possible, right? You can do things like using breach or SRIOV. Over here in our environment, as well as in the example, we are using the CMV breach. Of course, you can customize the MAC, right? So this is something that you can do if you want, or if not, it will be automatically assigned. You can also do things with the storage. How we have created the Windows VM over here in this case is that we kind of imported a QCOW2 image for the Windows, and we use it to spin up the Windows VM inside the pod, right? You can also do other things like cloning PVCs, right? So those things can all be done. You can just take a note that you need rewrite many, right? If you want to do live migration, we will do a quick live migration demo later as well on the pod, the virtual machine pod that's running within the environment, just to show that there is no drop in traffic, right? When we move the pod, right, from one worker node to another worker node that is running on bare metal, right? So we'll do a quick one later on just to show that this can actually be done. You can see over here that you can also specify, right, if you want more than one disk. So usually what you have is a cloud init disk, right, for you to set up the initial configurations. It could be things like the host name, what kind of SSH keys or password that you want to use in order to log into the target. You can set up the root disk. You can also have other disk that goes along. We can also do expansion of the storage that's needed. We will show very quickly as well, right? The PVCs that you can just expand. Let's say you start with 30 gig, you want to move it to 35, 40 gig, right? So those things can be done as well. And what is the boot source, right? So we'll specify all those things as well. Other actions with virtual machines, typical stuff, you will want to be able to stop, restart, migrate, clone, right? Or you want to check the console, right? So those things are possible. You can also delete the virtual machine from here. Those are things that can actually be done. You can give labels, right, to the virtual machines. For instance, if you want to create a service, right, within Kubernetes, you want to make sure that it's referencing to certain ports, right? So that will be done using the VM itself. I mean the labels itself, right? So after which you can take a look at also some of the metrics pertaining to this virtual machine, right? So you can see over here that we have individual view, right, on the utilization for the VM, right, that's running inside the pod, or it can also be an overview where we will show you in general what is the breakdown for the top 5, for instance, like who is consuming the most resource. This is about live migration, as we mentioned earlier, right? You could actually do a live migration, and you will need a read-write many storage. In this case, it depends on scenarios where you may need it when you are trying to evict resources from, let's say, a particular worker node, right? So, or you are doing some maintenance, for instance, or maybe the node goes down, it spins up on other place, right? So those kind of stuff will be the kind of scenarios where live migration will be useful. Not very different, right, from what you typically do today in the virtualized world as well. So this is Maltus, right? So we are able to use Maltus for additional network interfaces. For instance, for bridge, or if you want to do SRIOV, you can do that. In our environment that we are showing later, we will just be using bridge. You can set up VLANs for isolation purpose, right? Different network has different VLANs. You can use those things accordingly. On a high level, right, it kind of looks like this, right? So for instance, in this case, BR0 is the default, the SDN for OpenShift, right? And the BR1 will be something that allows you to connect to an external network. All these things are enabled by Maltus, right? So this then allows you to connect to multiple networks at any one point in time, right? In the next diagram, right, basically we are saying that you will typically see multiple networks being used in a real-life environment. For instance, you may have things like your management data, for backup, migration, right? So all these are different networks that is being used to ensure that the bandwidth utilization, right, it's enough for you to perform a particular action. You're not trying to do everything from a single NIC card. So again, this kind of maps back to the kind of things that you will probably be doing in a virtualized world where a VM has multi-NICs and all these different NICs are connected to different networks for different purposes, right? So we can do that using Maltus with CNI, right? And after which it's just going to appear as different NICs on the VM within the environment itself that we are looking at, right? So all this load is going to run on the worker nodes, and we will be able to kind of simulate, not simulate, but kind of have the same kind of requirements that we will have, what you currently is doing today, right? So we are also able to do things like a backup and restore. What's going on really is if you want to back up the entire namespace, right, where the virtual machine is actually running inside. We are able to today use what we call as OADP, right? It's an operator that can be installed with, from the operator hub. And using this, you are able to use the underlying Valero technology to go and do the backing up and restore of the namespace that has a VM. It will just restore the namespace and the VM for you, right, by doing snapshot of the volume that we have as the backing for the persistent volume, right? So this today is under tech preview, but nonetheless, we kind of tested. We know that this is going to work if you want to test this, right? So these are some of the features that we have. The next part is really on the demo. Is there any question before we just do a demo on this? There is no question. I just want to show you the environment, right? So you can see over here that we have a compact mode set up. Basically, I have 3 bare metals, right? The workers and the masters are all built on the same tree node. Of course, you can have it, separate. It's just that in our environment, we decided to build a compact tree node. In any case, for you to use OpenShift Virtualization, you want to make sure that the worker nodes is running as a bare metal, right? That will be the requirements that's needed for this to happen, right? You can then look at what I have inside. So this is my first master node, right? If you were to look at the network, right, we have actually set up a bridge, right? The CMD bridge that we refer to on the ENO1. So I have 2 NIC cards. The first one is actually for the OpenShift SDN, right? Then the next one is actually the one that we are using to show that you're able to access via the second NIC, for instance, right? So this is the initial environment that we have. let's just take a look at the environment itself. So this is the actual OpenShift cluster that's running. We can see over here that you are able to do the installation of OpenShift Virtualization by just coming to the operator hub, and then you just hit the install button. It will just set up the whole thing, right? So once it is installed, right, you will see that it is actually going to show up in the environment. So basically, the install operator will show OpenShift Virtualization being installed, right? We have set up the deployment and set up the hyperconverge, right? So everything will just be built. You will see all the different ports that is actually being deployed based on the operator that was installed. So then in our case, right, you will then see there's a new tab for virtualization that shows up after the operator is installed. So if you go to the overview screen,
I think bigger a bit. Slightly bigger.
Is it not showing everything?
You show. A bit small.
Oh, it's a bit small, is it? Okay.
Bigger.
Are you able to see it?
Yeah, can.
Or do you need it bigger? This one is okay?
Yeah, this is okay. Thanks.
Okay. All right. Sorry, I mean, I make it bigger. It's inside, it's a bit small. Okay. So if you were to go down, there will be information relating to this whole environment. You can see what are the VMs that's running. I have 6 VMs running, and these are all the different VMs, right? We have a RHEL 7, a RHEL 9, RHEL 8, Windows 2019, for instance. And it is able to give you a breakdown on the resources utilization across the different virtual machines based on the top 5, for instance. Right, so which are the ones that actually takes up the most resources, memory, what kind of file system is being used, storage throughput, the IOPS, memory swap, for instance. Right, so one of those things to mention over here as well is that I'm using our OpenShift Data Foundation, which is basically, is similar to the OCS that we have from the past, right? So this is running Ceph, right? So if you were to look at the storage classes that we are using, I'm actually using Ceph RBD as the default storage class over here. So the virtual machine persistent volume backing is actually going to be using RBD over here, right? And this is what we have. I'm using local volume set because I'm kind of using the SSD and the NVMe disk on this bare metal on the worker nodes, and then we are just forming a volume set and just consume on those things. On top of that, we have ODF with Ceph and all those things running, right? So different snapshot classes, right? We are using the RBD plugin snap class, right, to go and create those kind of content for the snapshot. So that is kind of how this environment will look like initially, right? So if you were to then go into each and individual virtual machine, right? So you have, for instance, over here, this is the test VM1. You can see over here that you're able to see the IP address, for instance, what kind of operating system this is using, right? The details relating to this particular virtual machine. Of course, we know that everything can be defined using YAML. If you want to just use a YAML to create a virtual machine, the pod, right, which is running this, you will be able to do that as well, right? So these are all the information required that's related to this particular pod that was created, right? If you were to look at it, over here, right, under the workload, you will see that these are the Vert launcher, right? So this will be the pod that's actually running. This particular VM is inside this pod, right? So if this goes away, then of course that thing will die off as well, right? So you can actually see that this is what this is, right? And if you were to look at it from a developer perspective, you can see that these are all the pods that's actually running within the environment. You can actually build other normal container workload that's running inside, and from here you can see the whole relationship and topology relating to that particular namespace that we have. It gives you a very good overview on what is actually going on within this environment. right? So going back over here, we can do things like a live migration, right? So you can see over here that this is running on 0 master node. So if you go into the console itself, again, it may be a bit small, but let's just do something like a ping towards the Google DNS, right? And then if you were to come back over here to the virtual machines, we can do like a migrate node to node, right? So then it's going to start to schedule, right, and move it to the next node that can actually allow this to be migrated to. So then it's just going to run the migration and it will move it from 0 to some other host accordingly. Right. So from 0, it moved to 2. Right. If we were to go back over here, you can see that there is 0% packet loss. Right. So throughout the whole migration process, everything is seamless. I move from one host to the next host, and there's no drop in the packet. Right. So this actually works. Right. We are able to do things like live migration quite easily in this case. Right. Other things that we can do, right? So in this case, we have a Windows 2019 servers. We talk about this being multi-NIC. So you can see over here that we are using E1000E, right, as the way to connect on the NIC card perspective. For Linux, usually we are using VirtIO, right? For Windows, we are using E1000E, right? So the second NIC card that I have, right, is actually connected on the ENO1, the bridge one, right? So that we saw earlier, right? That's running on the running on the host, right? So basically what will happen is that we build a bridge on this. And if you were to go and look at what we have over here, the console itself is going to show you the Windows piece, right? So we just do a Control Alternate Delete. We can then go into the machine. You can see that the IP address of this particular machine is actually 1069.151.3. But what we want to show is that we are able to do a RDP into it, right? So this is 1069.151.3, right? So we can then go into this as well. So you see on the back end, it logs, right? So essentially, this is the same machine that we are able to log in, right? But this is on a different network. This is actually outside of the Kubernetes internal SDN itself, right? So if I just turn on, let's say, we could do something like a test, right? And it actually shows up over here. It's connected. Everything is working properly. If I were to close this and I go back into the machine again, right? You can see that it's actually the same machine that we are talking about. So management of this Windows VM is totally possible, right? From outside, right? Because it's actually connected on the second NIC card. You have the full flexibility to connect to it or use this particular NIC or network for doing things like, live migration, for instance, just to make sure that you don't exhaust the bandwidth that's needed for other purpose, right? So, or you can use it for backup, right? So those are some of the stuff that can actually be done in this case, right? The same thing can be said for this two other VMs that we have, right? So this is running on 151.2 and this is running on 151.4. So same stuff, we are able to just SSH into 1069.151.2, right? So you can see over here that this will then be the VM that we are talking about in this case, right? So over here you can see that there's nothing, right? If I were to create a file, right? The same stuff, right? So from here, you're able to just see that the file was created inside the VM. So it's the same kind of VM, so you're able to manage Windows, you're able to just connect over SSH for a particular VM, like in this case as well, right? So other things that we can do, right? We could just show a quick one, right? With Wizard, we are actually able to select from a different source of templates, right? You can see over here, I have RHEL 7, RHEL 8, RHEL 9, CentOS. I have Windows servers as well, right? All that's needed is that you need to create the boot source, which in this case, right, you can see that you need to specify where this is being booted from. Right? So all these things are going to be something that we can either import.
Because I think Andy has one question that he says, whether can the VM be pushed into like a image registry like Quay, like container images, which I believe can it actually be done. But I believe it's more like
no, but this is like a QCal tool, so it's going to be more like a image persistent volume, or you can download from. It's not exactly a container. Yeah.
Yeah, it's not exactly like a container image. It acts exactly as how you expect it from a virtualization layer. More from like if you create templates, right? Then
you could also do that, but the thing is usually you want to create PVCs, right? So let's say if you want to do this, you can put it inside the registry and then we just pull it down, right? So you have a few ways to do it. In my case, right, I was using a QCal and after that I convert into a PVC. But if you want to, you can just do it from a registry as well, right? So
I think the idea of creating the manifest, like the YAML template, like if we based on that, we can also deploy the virtual machine based on the full YAML template, right, and manifest file.
Yeah, but this is actually talking more around the source, right? So in this case, for instance, if I want to deploy from a template, like in this case over here, you want to be able to ensure that this is actually done beforehand. And then you can just write the YAML to deploy the VM by referring to this template or boot source that we have. Right? So behind it just creates a PVC and a PV that has all these things being deployed inside. So what I did was I was using a local file for the Windows VM, but definitely if you want to do all this prep work yourself, you can do that as well and just put it inside the registry and we just pull it from there. So it depends on how you want to do it, right? So there are other advanced storage settings that you can set, which depends on kind of storage class that you're using for this. It will work as well, right? So, or you can even do CD-ROM boot source and try to install from this. Right. So actually, I know we are kind of running a bit short. I just want to quickly show other things as well because we are about time as well.
Gao Ho was asking whether can we see the image stream in OpenShift namespace in this namespace, I guess. Gao, is that what you're asking? Like in this namespace, can we see the image, the ISISO?
Yeah, I'm very curious about all these image source, right? So it seems like they are actually. Can we see the image stream whether there is an image for this virtual machine templates inside?
Yeah, there will be. So after this is created, you will create one.
Okay.
Yeah. Okay. Quick one. I just let me see what is inside the agenda. So okay, other things that I just wanted to very quickly show right before we run out of time is things like the PVCs, right? So we know that we are able to just expand on the fly as well, right? So if you have the console over here, you can see that this guy is running 40 GB, right? So we can on the fly just expand it, just like what we do for any usual workload within the Kubernetes environment, right? We can say that I want to make it 45, right? It will just go and do the expansion, and over here immediately you can see that it actually expands from 40 to 45. So of course you still have to go and manage the file system up expansion yourself, but it's actually very convenient, right? When you want to just expand on this, it just goes and expand in this case. You can also do things like create a snapshot, right, of the PVC. It will just create a snapshot as well, right? So it's almost instantaneous. You will see that the snapshot has been created. Of course, if you want to change the CPU or change the RAM, it requires a reboot. You have to update the YAML files. So those are things that can be done as well. What are the other things that we wanted to show? Yeah, so changing the memory, for instance, can be quite something that can be done quite easily as well, right? So let's say if you just come here and you wanted to change it to some other values, right? So right now it's 2 GB. You can actually increase to 3, for instance, right? If you save it and if you reload, it's able to tell you that this thing requires a restart, right? And you can just do a restart from here, for instance, and it's actually going to be able to just update the memory of the VM for you after that. Right, so those are the procedures that can be done quite easily. Actually, I still have, we're running out of time. I think almost.
Is that everything?
Still have one last thing that we can show, which is around the services itself that's running within the environment. So I think we did mention around the fact that you know, we have this web service, right, that is actually tied to the two hub that is running the virtual machine, right? So one of those things that you can actually do is you can just spin up a test port in other namespace, right? In this case, these are all running in the code VM namespace. I'm running another port in the default namespace. And if I were to curl against, you know, this particular web service, you actually see a response that's coming back from web app 2, right? And then if you curl again, it actually comes back from 1. So this becomes a way for you to consume the service that is being given by the VM itself, right? So it allows you to be able to just use this thing, you know, together with VMs and the other containers that could be running within the environment, right? So I think that is also something that is good to show. And perhaps one last thing is just, I think we didn't actually create a VM live, right? So if we were to just create a live VM quickly, you can do things like customize the virtual machines, right? And then you can say that, for instance, this is test VM2. And you can say that the flavor that I want, right, 1 or 4, right? Or it can be something that's custom, right? You can customize the CPU and the RAM as well. Or that you can just say that this is my medium t-shirt size flavor, right? After which we can add NIC cards. You can see over here that I'm using the CMV bridge network connections. You can specify the MAC address if you want, right? And after which we have the way to specify more disk, right? So for instance, I want to create a blank PVCs, or I could also do things by importing direct from, let's say, the registry that I think Andy was asking earlier on, or to use other things like pulling from a URL, right? So this can be something that you can do with the rel qcal2 image. You can specify the URL for it to actually pull from there, for instance. Right, so in my case, I just want to do a blank PVCs. I can give it 30 gig, right? And then I specify the storage class that I'm using. I can do add, right? So this VM will then have 2 NICs and 2 disk. Then we will just specify, for instance, like the cloud user, what kind of password, right? So this is going to be a random password that will be created. We specify the host name, and we can specify the SSH keys that we want to give in this case. Sysprep itself, if it is related to Windows, you can do updates on the auto unattended XML answer file for you to do installation without any people. Basically automated way of doing things with unattended XML, right, for the Windows sites. So in this case, we don't have to, right? The SSH, we want to expose port 22 in this case. Hardware device wise, right? If you have GPU running, I don't have GPU running in my environment, but if you do, you can also add the GPU device as well, right? After which you just have to look through this whole thing, and if you're happy, you just have to create the virtual machines. You will start to create the whole virtual machine itself by going through the various events, like setting up the required NIC cards, the required disk and everything that's needed. So after which this whole machine is going to be built, right, on the fly, right? So then you have a new VM that's created based on the requirements that is given. You can see that now it has the if0 and if1, and after which it will be able to tell you that you are able to log in, right? So from network interfaces, you can see these are the attributes. The disk that is tied to it, where you have another disk 0, the 30 gig disk that we were talking about on top of the root disk, right? So we are able to create this thing quite easily as well. Over here, this is the second VM. It was just being created as we saw earlier. I know we exceed the time. Just want to make sure that I cover the stuff that I wanted to show.
Yeah. Thanks, Anthony. I think Robin, you also answered quite a few questions. Andy, I hope that answers your question as well. On the whether we can use the a Query IO registry for provisioning the virtual machines itself. I think Rahul also has a question on whether we can support, or whether do we support assigning raw fiber channel like LAN disk to VM, which I believe is
we need to use the CSI,
CSI
plugin, right?
Yeah.
So it has to be compatible with container storage interface, right? So the CSI, if it is available, right, then we will be able to integrate with that kind of storage. There is actually a link with that information. I don't have it.
At the end of the day, I think Rahul, it does just it still abstracts that layer, right, for storage, right? It's still going through the Kubernetes way of presenting storage as a PV, right, or PVC to the VM itself. So that is how the VM will get the storage. Is there any other ways? I think that's usually through the PVC, right?
It will be via CSI. So
CSI,
actually,
yeah.
I don't know whether. Let me see.
So before
something like this,
Yeah.
right? So you have a list of all these different drivers that's needed for you to work, and it actually shows you, for instance, what are the different brands that's available, right? We do know that some customers have this kind of requirements because they have existing storage that's running, and they want to reuse it rather than using what we just demoed, right? We were using Ceph, right?
Okay, so before I because I know that we are beyond time already, just quickly just want to share my screen on the So of course we appreciate your feedback. If whether is there enough, you want a longer session or you prefer another day, or whether is the content okay, right? All these things, we appreciate your feedback, and we also look forward to seeing everybody again, right, for the next session sometime soon, right? If you have take some time, right, to give us some of your feedback, right, it would be great, right? We'll still be here, right, to answer any of your questions, right, if you still have time, right, to be with us here. You can stick around and ask us questions. We'll be around. But if not, I would like to thank everybody, right, for coming to the meetup, and I will see you all for the next session, right? Thanks, everybody.
Thanks, guys.